Creating user interfaces for applications on the Canute Scientific. The user interface you create for your application is vitally important as it is the very means by which the user interacts with in order to utilize your application. So it needs to be intuitive in a sense that it's easy to use. Now, fortunately, with the default libraries that are pre-installed with the Canute Scientific, specifically Canute Lib, it is very straightforward to create your first ever user interface for an application you're developing. In order to create a Canute Scientific application, you can do so using one of either two programming languages, those being Python or Bash. For the purposes of this explanation, I'm going to assume you're using Python, as is the language I am most familiar with and the language I recommend using. The reason being that the syntax, the actual means by which you write in the programming language, is more intuitive than for Bash, which is a little bit more complicated. However, the concepts for both languages are the same. That is something you should be aware of. In order to create a user interface for an application utilizing the Canute Scientific, we can do so via one of two means. First of all, we can do so using YAML, and this will work both in Python and in Bash. Or, if using Python, you can use a class called screen. Regardless, we utilize the Canute Lib library in order to do so. Ensure that this is imported within your application, regardless of what language you choose to use. Now, to simplify things for the purposes of this application, YAML and classes essentially achieve the same effects. They are means by which we can group a series of related data, in this case, essentially instructions on how to create a basic screen or user interface for a Canute application. However, do be aware, if you're not already, that under the hood these are very different concepts. Classes are much more capable than YAML. They can do all sorts of fancy things that are beyond the scope of this particular example. And they are really both concepts that you should go away and research before utilizing. This is just meant to be a very basic explanation to showcase how simple it is to create interfaces. But in order to do so, we first need to define a title for our screen. Now, the title is the text that is displayed on line 1 of the Canute or the very top of the monitor. Essentially, obviously, both outputs are mirrored against each other. You can then optionally give your screen a description which gives a little bit more context to the title and sits directly underneath it on as many lines as it occupies from line 2 onwards. Canute Lib supports multiple different types of screens intended to be used for different use cases within a user interface. The types of screens include menu screens, input screens, radio screens, and checkbox screens. Depending on the type of screen you wish to implement, you'll want to either define the YAML or the class property menu for a menu screen, radio for a radio screen, checkbox for a checkbox screen, or input for an input screen. Within this subsection of the screen, there are various fields that need to be defined for all elements on the screen. For menu screens, you simply need to define the series of menu options you wish to include within your menu. Each of these options should have a label field which defines the text that is displayed for that menu option. So a help menu option would want to have the label help. there's also a value field, which is used to define the programmatical value that this option will hold. And that is the value that you would use in event handling, which we'll get onto in a minute, when the user selects an option on screen to determine what they've selected. And optionally, we have a status field. Line 9 of the Canute Scientific is reserved for providing what's called status text, and this is just intended to give additional context to what is currently selected on screen. It is completely optional, and if it isn't utilized, line 9 will simply be used to display the subsequent element within your interface, but if it is occupied, it'll be reserved for the status line, and your interface will simply be displayed on lines 1 to 8. But it's certainly handy, especially for complex circumstances, to utilize that status field. In terms of the other three types of screens, these are form screens. Now, the same rules apply to what I've just said. So each checkbox, radio button, or input field requires a label and a value field, and optionally a status field. The difference to the menu screen is that some of these fields, or some of these types of forms rather, have additional values that need to be set. So, for example, let's take a look at what is a checkbox. Well, a checkbox is an element on the form that the user can select. And out of all the series of checkboxes on the form, the user can select as many or as few as they wish. Therefore, the checkbox has an additional field known as checked, which can be set to either true or false when the form is created, and its value of which can be changed when the user interacts with it. Radio buttons are similar in that they have a field known as selected, which one again needs to be set to either a Boolean value, true or false, depending on whether it is selected or not. However, radio buttons are different to checkboxes in that only one in the series that are displayed on the screen can be selected at any given time. So, when you are creating your form, ensure that only one of however many radio buttons you've included on your form is set to true. Otherwise, your program will crash, which nobody wants, do they? Once again, when the user interacts with the form, they will have the ability to change which radio button is selected. When they select an unselected radio button, the currently selected radio button will be unselected, and the one they just selected will obviously be selected. One final caveat I should mention regarding input fields is their value field is unique in that the text that this is set to not only defines its programmatical value, but also defines the value that is displayed within the interface, the value that the user has entered within the input field. So let's say we have an input field known as name. If the value field of that is set to Ben, then that name field will be filled in as Ben on screen and also be known as Ben programmatically. This is pretty self-explanatory in that it's useful when you're doing your event handling to check what the user has entered within said input field. The final thing you should be aware of where forms are concerned, which obviously doesn't apply to menus, is that they have an additional buttons subset in their YAML or class, whatever you're using, that needs to be set to. And these buttons define the different form actions the user can take once they've entered their input fields, set their radio buttons, or filled in their checkboxes. It makes sense when creating any form to have some sort of submit button. Also, obviously, maybe a back button to go back, or in the case of input forms, a clear field to clear anything the user has entered within the input fields. However, feel free to add any other buttons to your forms that you think are relevant given the context. For example, you may well want a help button on your form that displays a help screen that gives a little bit more information on how to use the form you've got on screen and how it applies more broadly speaking to the wider application, if it's within a wider application, so to speak. Once you're happy with your screen, you then need to implement some rendering code that renders this screen to the user. And this will differ slightly depending on whether you've created your screen using YAML or the Canute Lib screen class. If you've created your screen using YAML, you need to take the YAML you've got, feed it to a method known as config screen, and that'll render you out essentially the equivalent of the screen class that you will alternatively have created. Once you have a screen class either rendered from your YAML or created manually, you then feed that to a Canute screen method, which renders the screen out to the user. No fancy code or anything like that needed. That is literally it. For those of you who aren't aware, a function is just a named piece of code that does a lot of fancy stuff in the background, in this case rendering the screen out to the user. It's then up to the user to interact with said screen, and once they do so, and they've moved to another screen, you will get a couple of values rendered back in what is known as a Python list in the case of Python. Every value within this list up until the last refers directly to the data the user has input or selected in the case of the form. So it may be a radio button value, the series of input field values they've select, or rather input, or the checkbox values they've selected. The second value will be the button they've selected. So have they submit the form? Have they cancelled out of the form? Or have they cleared the form? You need to handle these accordingly using if statements. This is not a programming tutorial. This is a Canute Scientific user interface development tutorial, so I'm not going to go into any further detail regarding the programming concepts I've discussed there, but essentially you need to handle those values accordingly depending on the proposed functionality of your application. Finally, I ought to caveat that it is important to structure your Canute Scientific applications in the appropriate way. This, once again, is beyond the scope of this little tutorial here. However, there are plenty of examples on how to do so within the console Canute Lib repository and a lot of the other public repositories available on the Bristol Braille GitLab, so make sure you have a look at those before you get started developing. There's obviously, without saying, also plenty of examples on here of user interfaces, and having a good look at these will help you get comfortable with developing your own. But that brings us to the end of this tutorial. I hope you have found it useful. If you are planning on getting a Canute Scientific, hopefully it has reassured you that creating screens is relatively straightforward. But I'll catch you again soon with another tutorial on developing applications for the Canute Scientific.